part 1, the central limit theorem and its use. The basic application of central limit theorem to convert any probability density function or any distribution into perfect Gaussian distribution to analysis the noise in digital communication, as well as this theorem is very helpful to analysis in noise in sampling theorem. Now, in last lecture also we have find out the error function for the continuous random variable as well as the discrete random variable. Now, as well as the complementary error function. Now, today we start with the Gaussian distribution, Gaussian probability density function. This type of probability density function of Gaussian distribution is basically used to find out the used by continuous random variable. Okay, the basic application of this Gaussian PDF means Gaussian probability density function in digital communication to analyze the noise. So it is used over continuous random variable. Okay, and the main application of this Gaussian PDF, that is Gaussian probability density function, is to analyze the effect of noise. Analyzing the effect of noise in digital communication. So, Gaussian PDF is given for continuous random variable, that is CRV, f of x 1 upon under root 2 pi sigma square e raised to power minus x minus e whole bracket square divided by 2 sigma square. So that is the formula to calculate the Gaussian probability density function, that is denoted by f of x into x 1 upon under root 2 pi sigma square e raised to power x minus m whole bracket square divided by 2 sigma square, where m is a mean, where m is a mean and mean of random variable. Okay, and sigma square is a variance of random variable. So this is a very important formula to calculate the Gaussian probability density function for any continuous random variable, where you know the mean of that random variable and variance of that random variable. Now we can draw the perfect shape of the Gaussian PDF. So some of the property which is very helpful while analysis of a noise. Gaussian medium at center is peak value. So first property, the Gaussian medium, it is a mean function. When mean value, peak value at x is equal to m. So this is a peak value. This is f of x into x, that is probability density function, and this is a random variable, and here x is equal to mu. So the first property, that is the when it is a bell shape when the peak value is equal to mean or average value. So that is Gaussian PDF. Okay, and so this is x1, x2, area under of x2 and x1 and x2. So this is a typical view for the your Gaussian PDF. So what are the properties? So first property, the Gaussian PDF. Gaussian probability function is a bell shape. If you see this is a bell shape when at peak maximum value of the random variable is equal to mean. That time the shape of this probability density function for the Gaussian is a bell shape. The second property, the Gaussian PDF has even symmetrical above its peak. So it even symmetry above its x is equal to peak value, maximum value. Okay, so f of x into x, that is x minus sigma, and f of x into x, that is x equal to n plus sigma. So this is the symmetry property. Now the third property, for the area under the curve is Gaussian PDF is 1. So area under curve, it may be 100% or 1. So minus infinity to plus infinity under Gaussian PDF f of x into x is equal to 1. This is the third property. Area under the curve of Gaussian PDF. Now the fourth property, when the probability of obtaining x above and below of random variable is mean value. The probability of random variable x is to be getting above and below mean, that is m, that is equal to m. So probability that of x random variable, it may be below that is m, or probability of x is equal to m, that is 1 by 2, because this is a symmetrical at peak value. So that is, so this is a fourth property. Now the free property. The probability of observing x between two variables that can be given, two random variables. The probability of x between two random variables, any random variable, between two random variables, like x1 and x2 is given by is equal to probability of x1 x2 is equal to integration between x1 and x2, that is f of x into x dx. So these are the 5 properties which is to be remembered. First property, at peak value the curve shape is bell when peak value is equal to mean. Second property, the area under the curve is 1. Third property, the probability of random variable x is below and above is 1 by 2, and the probability of observing x between two random variables, that is here, is given by probability of x1 lies between integration x1 into x2 f of x into dx, where f of x into dx, it is a probability density function of continuous random variable. So these are some properties which will be very useful while dealing with the Gaussian field. Now, one of the application which is to be seen. What was the application? Suppose if you transmit a digital data or a communication channel in the form of digital transmission. So digital format means if the information is transmitted present is a 1, if information is transmitted it is 0. So this is a digital format. So whenever the noise is added in this time, so what will be happen? How the detector or receiver decide which data will be received? So that purpose it uses the concept of threshold. If you observe the Gaussian medium, here at x is equal to 0, the value of mu is maximum. So here the peak value is maximum, but at the value of x random variable is increasing, that time the value of probability density function is decreasing. Okay, so that time how to decide which data will be received? For that concept we use the threshold concept. So here x, here this area remain is undefined, so error will be occurred. So that time we use the concept of threshold value or threshold detector. So what is the concept? It is very helpful for the optimum receiver as well as to find out the perfect when noise is added in a digital transmission data. So this is the boundary. So this is voltage minus A by 2. This is a 0. This is plus A by 2. And this is your Gaussian field. Binary 0 and binary. So whenever the output voltage of a detector is plus 1 by 2 and some noise, this figure, you have to clear that the concept what is also will be said. So this is a Gaussian period. Okay. This is voltage at minus A by 2 and this is voltage plus A by 2. So this is the value of 0 maximum PDF. Okay. So whenever we transmit a bit 1, that time the detector voltage, that is threshold voltage, this voltage will be plus some noise. So that time the detector find out the received word is binary 1. So output of the receiver or detector is 1. So if the value of detector resultant output is minus A by 2 plus some noise, that time the detector confirm the binary 0 will be received. So in this way, this concept which is used in terms of bipolar means 2. So here we use the threshold concept. So threshold concept says that when the noise will be added in digital transmission signal, that time it will be difficult which bit is transmitted. So that time we use the concept of threshold. Now the third concept, that is the statistical average. The statistical average of your Gaussian PDF says that the statistical average value E of x is equal to normal mean, that is denoted by small letter. So that is calculated by E of x, that is the statistical average value for the Gaussian PDF, minus infinity to infinity x 1 upon under root 2 pi sigma e raised to power x minus mu whole square divided by 2 sigma square du by this, that is equal to normal mean. So that is it. Statistical average. Third, the Chebyshev inequality. This term is used whenever you do not know the probability of between two random variables. That is, suppose x1 and x2 are the two random variables. But definitely we calculate the probability of third random variable that is to be unknown and which do not define a proper probability density function. That time we use the concept of Chebyshev inequality. So Chebyshev inequality states that to calculate the probability density function, so probability of any random variable, that is x, which is lies between two intervals x1 and x2 and do not define a probability distribution or probability density function. That time we use the concept of Chebyshev inequality. So this Chebyshev inequality very useful to calculate the probability of any random variable which is lies between two random variables, two known, and where the any probability density function or probability distribution is not given. So that time we use this concept. So probability of x minus mu mod is greater than or equal to c, where c is the constant, is greater than or equal to sigma square into c. So this is the about the Gaussian PDF. What will be the use of the Gaussian PDF? Its properties. Then threshold value, it will be very useful while noise will be added in digital communication, and statistical average is equal to the normal mean, and Chebyshev inequality is very useful to calculate the probability of any random variable which is lies between two probability functions for the continuous random variable. So in this way we have come to the four basic terms which is related to the Gaussian medium.